Hello, Dr. Lane. Welcome to another assessment. Today, I'm doing problem 19 from the homework, and what we were given is the mass of the planet, the mass of the star, and the location vectors of both of them. And so there's a planet with a large mass, a star with another large mass, and we're just asked a couple questions of what we can know about these two from what we've learned. And A is, what is the relative position vector r pointing from the planet to the star? So to find the relative position vector, you do the terminal minus the initial, you just do a vector subtraction, and you end up getting this for r. And B asks us, what is the distance between the planet and the star? So the distance, that's really the distance formula. It's also the magnitude. So we already found the distance between the two with the relative position vector. Well, that's the distance vector form. And then you got to change it into regular form, which you use the distance formula. And it ends up being 7.3 times 10 to the 11 meters. And that's also the same as the magnitude, which helps us out for C here. C, what is the unit vector r hat in the direction of r? All you got to do is do the relative position vector divided by the magnitude, which just happens to be the distance that we just found. End up with this here. It's a little bit off for what the definition of unit vector is, but that's what we came up with here. When you're working with big numbers like that, you're going to be a little off, but it's not off enough to where it matters. For D here, what is the magnitude of the force exerted on the planet by the star? So we use the gravity formula because they have a gravitational pull between the two, and we use the constant for G, the gravity constant, which is 6.7 times 10 to the negative 11, and multiply that by mass 1, mass 2, the planet, the star, and divide that by the relative position vector squared. And after calculating that, plugging it into the calculator, you get 2.5 times 10 to the 21 newtons. That is a lot of force. But would you expect anything different from such huge masses? We're working with big numbers here. This is going to be a lot of force just from the gravity. All right, and then E, what is the magnitude of the force exerted on the star by the planet? So this is exactly the same formula. You're just changing mass 2 to mass 1, and it's just changing the order on the gravity formula. So you end up with just the same answer. It doesn't change. They're each putting the same amount of gravitational force on each other. And F, what is the vector force exerted on the planet by the star? So you do the gravitational force and multiply that by the unit vector. It's changing it back into vector form, and you just multiply those out. We just solve for that, and then times the unit vector. That'll give you the force exerted on the planet, the vector force exerted on the planet by the star. And G is, what is the vector force exerted on the star by the planet? And that would be the exact same. They got the same force, same unit vector. The only difference is the unit vector is going in opposite direction. So you just change the signs on the two, and that's all you have to do, because all it did was change the direction. And yeah, that's it for today. Come back next week.